A new prototype. But what does it mean?
Implementing an alternative suspension system sounds crazy, especially when you consider there might be some corruption. But to go further, to innovate, we may have to go a bit wild.
Absolute freedom in deciding the prototype's behavior, which leads to an improvement of the timing and braking system by managing the suspension compression. Improves the force and the distribution of the stress, weight reduction and lowering the center of gravity, greater agility, optimization of the space for all the components.
The implementation of this system gives the team a revolutionary character as it challenges the current state-of-the-art in competition, and it serves as a springboard for the industrial development of this technology.
But we didn't want to stop there. We decided to continue optimizing the performance of our bike, reduce weight, improve the space, increase rigidity, etc. After studying many different viable options for several months, we finally decided to build a twin-spare hybrid chassis that combines composite materials with sheet metal and laminate.
But it's not all about improving the design. We also wanted to learn by facing new challenges. For the first time in our history, we decided to create and design our first carbon fiber tail using PETG molds, all designed by us. In this way, we retained the best qualities of our bike: lower weight and high strength. We also decided to manufacture a multi-adjustable foot pegs in pressed carbon fiber, with the aim of lowering the center of gravity of the bike-rider combination and reducing weight.
Another important feature of the new bike is its string arm, chosen for its structural rigidity and its better distribution of forces.
We are looking for a controlled squat behavior with small angles to keep the engine low and, with it, the center of gravity of the whole bike. In addition, a nice tamper has been added at the end of the string arm to help control the rear end vibration and improve traction. Its main innovation is the symmetry, which optimizes the use of the plates according to the needs of each side of the bike. To improve the rear suspension, the rocket linkage system has been chosen with an extendable linkage that offers greater adjustability and provides unity curves more in line with those desired. The geometry of the linkage system has been optimized using a mechanism simulation program developed in MATLAB, which has allowed the final design to be arrived at by means of topological progress.
The engine is one of the most important parts of the bike, so we have focused our designs to maximize the volumetric efficiency. This allows us to reach a higher top speed and acceleration.
In order to achieve it, we have designed a double air intake duct system. On the other hand, a pre-chamber has been implemented in the airbox to slow down the air before the filter, which reduces the pressure drop. Then, a main chamber remanipulates the air and ensures regular torque and power delivery, which offers higher internal pressure and a higher usable volume.
Finally, a variable intake trumpet has been developed so that its length can be dynamically modified depending on engine speed to optimize performance in different operating ranges. The exhaust features a power bomb design with a single outlet megaphone-sized silencer. This setup enhances performance by improving the scavenging effect, while also reducing noise without compromising power gains or torque stability. The main objective of the aerodynamics department is to increase straight line speed. After analyzing the previously used fairings, the one chosen provides the best coverage of the rider legs and shoulders, with the lowest coefficient of aerodynamics drag. To this end, a British-inspired front mudguard was designed to reduce aerodynamic drag and allow for easy adaptation. On the take-hold, fins were added on each side to reduce flow separation and the width of the wake generated in a straight line.
Finally, the electronics of the new prototype had been designed to improve the system's diagnostic and performance by incorporating sensors for front and rear suspension travel, front and rear tire pressure, and front wheel brake pressure. We also developed our own data collection system. This will reduce cost and allow us to customize functions of the data logger, allowing us to get the most out of this system.
But this is only the beginning of a winning bike
in both racing and innovation.